Hello all, welcome back to the channel. So today we will be solving this lit code question number 14, longest common prefix. So the question states, write a function to find the longest common prefix string amongst an array of strings. So input is array of strings, and if there is no common prefix, return an empty string. So what is a prefix? A prefix is a sequence of characters at the beginning of a string. Prefix can be a single letter or group of letters. Let us take this as an example. So we are given an array of strings. So flower, flow and flight. You can see that the common prefix among all the string is FL. In each of the given strings, FL appears at the beginning. Okay? Therefore, FL is the longest common prefix. To further elaborate, like after the common prefix FL, the next letter in each string is not common. For example, flower has O after FL, flow has O after FL, flight has I after FL. So any additional characters beyond FL do not form a common prefix among all the strings. Therefore, FL is the output of the function. I'm not sure if you have referred my previous videos on how I solve coding question on LeetCode or any other coding problem. I will link how to start your approach to solve any type of coding question in the interview. I will link this in the description. The first step is ask clarifying questions. Okay, and the common suggestion everyone gives is think out loud, but you have to present your thoughts appropriately. Just don't talk anything just in the name of think out loud. Okay, you have to show your interviewer how you approach your problem, how you take his suggestions. Okay, because he is there to help you, so make sure to take advantage of that. So let's move over to step number 1, which is ask clarifying questions. For this problem, we can start with, are all the strings lowercase or should the function be case insensitive? So it is clearly, like we can see here, it only consists of lowercase. Okay. Are the strings limited to ASCII characters or should the function support Unicode characters as well, like anything other than just the alphabets? So I think they have not mentioned here, but they have said that it's English letters. Then you can just ask what is the maximum number of strings that can be included in the array. So this is an important question because they have already mentioned the constraints here. So why it is important? Because knowing the maximum number of strings can help in assessing the memory usage of your solution. Like if the number is very large, you may need to consider memory efficient ways to store and process the strings to avoid running out of memory. And also knowing the maximum length could influence your choice of algorithm. For example, if the string are known to be short, a straightforward brute force approach might be sufficiently efficient, whereas very long strings might require a more sophisticated solution to avoid quadratic time complexity. So make sure to ask this question. This will show the interviewer like you understood the problem and you are thinking about all the possibilities and gathering all the requirements before jumping over the solution. So now next step is call out assumptions. So for this, they have already mentioned if there is no common prefix, then we can return an empty string. But there would be some assumptions which we can let the interviewer know. For example, for this problem, one assumption could be if the array is empty, then the API should return empty string. And I see they have not mentioned anything about like leading or trailing spaces. So you can just mention to the interviewer like, I'm assuming there are no leading or trailing spaces we need to handle here. So now the next step is we need to explain the interviewer what algorithm you are planning to use, and make sure to use an example while explaining your algorithm. Also try to cover time complexity and space complexity while explaining the solution. Don't wait for the interviewer to ask you these questions. Also, if you're using any brute force approach at the very start, then try to explain the interviewer what optimization you would like to do, and if there is time you can actually optimize your algorithm using those techniques. Also try to mention what are the limitations of your algorithm, and also if you are using any data structure, try to explain what is the efficiency of that data structure. Okay, now let me start explaining this problem using this strategy. So first I will cover all the edge cases. For this problem, if the array is empty, then I would return this empty string, or if in an array there is just one word, then I can just return that word as the prefix. So when explaining your algorithm, you can start directly by taking an example and demonstrating how you would reach the solution. This approach involves explaining each loop and its outcome for the given example, and eventually what the output will be. Alternatively, you can use a pseudocode to explain your solution, which I prefer because in most interviews you require a working solution. And by using this pseudocode technique, you can quickly fill in the missing parts if you get a go from the interviewer like the solution looks good, and then you can run it. So for this, I will take first word in the array as a prefix, and I would store it in a variable, say prefix, something like this. And this I would use as a reference for comparison. Like I will iterate through each character of this prefix using a for loop. Something like this, for int so for each character position I in the prefix, it will retrieve the character here by using char at API of the string. It's the inbuilt API. So within this loop there will be one more loop, say inner loop, which compares this character C with the character at the same position in all other strings. So it would be something like this, for int j equal to 1, because character at 0 index is the prefix, so we will start comparing from first index. So if this I exceeds the length of any string, or if the characters don't match, then the function returns the prefix found so far. So to do that, I will maintain a variable named result, you can say result, throughout this comparison. I will use a string builder to do that. So first comparison would be to check if this I doesn't exceed the length of any string. Suppose now I is pointing to E and there is no character at the fourth index for this flow word. So in such case we have to return the prefix found so far. So which we would do by using this result variable. So it would be something like if I is equal to length of any of the word in the array, then we know that it has exceeded. Or there would be one more scenario that the characters don't match. So here like 0, 1, 2. At the second index you can see 0, 0, I. So for the flight, the character at second index doesn't match. So we can do that comparison too. So for that we would just use again that char at API. So we would take that word and check at that position what's the character, and if it's not equal to the character which we are comparing that with, then we would return the prefix found so far. And if everything goes well, then we can, like if all the strings have the same character at position I, then we can just append that character C to the result, and at the end we would just return result as the prefix. So there were some typos when I was trying to run this solution. So for example, this length should have round brackets around it, and I missed adding return here. Also same for the string builder, which you can fix, like it's just treat it as a pseudocode and then you can fix it. Usually during the interviews they provide IDE, so you can run your solution as many times as you want. It shows the what is the error and you can fix it. So yeah, so this is the algorithm. Let me run the solution and check. Yeah, it's executed. Now let me talk about the time complexity for this one. So the outer loop here runs through each character of the string. Let us say the length of the first string is L. The outer loop runs L times, and in case of inner loop, what is happening is for each character of the first string, the inner loop compares this character with the corresponding character of all other strings in the array. If there are n strings in the array, then the inner loop will run n minus 1 times for each character of the first string. So in the worst case, the inner loop will run completely for each character of the prefix. The length of the prefix string is L and there are n strings, then we have total L into n minus 1 as the time complexity for comparison. That's the time complexity. And in case of space complexity, only additional space used by the algorithm is the string builder, which stores the longest common prefix. So the maximum size of result will be the length of the first string, that is L. So this is time complexity, and space complexity would be L, and like other variables are just the primitive variables like I, J, C, and they are just constants. So O of L would be the space complexity for this algorithm, and we can just take it as L. N into L would be the time complexity for this algorithm. Now coming to the last point, which is potential improvements and limitations. So first let us discuss the limitation for this. The current approach assumes the first string in the array, like the potential longest common prefix. So if the first string is significantly longer or different from the others, it might lead to unnecessary comparison. So like there is too much dependence on the first string. Also like it this algorithm involves character by character comparison. Like for each string, we are comparing the characters, which might be efficient if the common prefix is very short compared to the length of the strings. Yeah, and optimization would be like we can optimize the solution by checking for the minimum length string first and limiting our comparison to that length. Also, we can use a binary search approach to find the longest common prefix. This can reduce the number of comparison by checking the middle point and adjusting the search range based on the result. Also, one more good approach would be using a divide and conquer strategy, like to split the array into two halves and find the longest common prefix for each half and then combine the results. This can help to optimize the comparison.